Today we will discuss one of the most important reaction in the class 12 organic chemistry, that is haloform reaction. You may call it as an iodoform test or hypohalate oxidation, whatever it may be, all are same. Okay, so here what is this haloform reaction or iodoform test? Here it is a test or a reaction. It is given by the aldehydes and the ketones. It is given by the aldehydes and the ketones containing 3 alpha hydrogens. Means here like this. If it is an aldehyde or a ketone, it should contain 3 alpha hydrogens. I told you functional group attached carbon is alpha carbon and the hydrogens attached to the alpha carbon are alpha hydrogens. So what is the condition or to exhibit this haloform test or to give a positive haloform reaction? So here it should aldehydes and ketones should contain 3 alpha hydrogens. That is the first condition. Okay, in presence of iodine, NaOH or base here or KOH or maybe calcium hydroxide, okay, or NaOI, KOI. Whenever aldehydes and or the ketones containing 3 alpha hydrogens are treated with iodine in presence of a base, here leads to the formation of an yellow color precipitate which is generally known as iodoform. So this is called as iodoform test. So here it is an yellow color PPT, precipitate, yellow color precipitate, and it is the characteristic of here it is the positive iodoform test is given by the aldehydes and the ketones containing 3 alpha hydrogens. And also here now what is the aldehyde which gives the positive iodoform test? The only aldehyde which gives the positive iodoform test is ethanol. It is acetaldehyde, because aldehyde means it should contain to this C double bond O hydrogen will be attached. On the other side you should have 3 alpha hydrogens. So the only aldehyde which gives iodoform test is ethanol or acetaldehyde. So here whatever the ketone, here this reaction is given by many ketones containing CH3, means containing 3 alpha hydrogens. Okay, and this reaction is also given by some of the alcohols of this type. Okay, I'll tell you how to write the structure for this one, how to write the products for this one. Okay, so first thing, what is an I think you got one clear idea what is a haloform reaction or the iodoform test. So here it is the iodoform CHI3 and yellow color precipitate will be formed, and the condition is it should contain 3 alpha hydrogens. Now how to write the product? I'll tell you in a simple way how to write the product. Okay, for example, let us take CH3 acetaldehyde and you are given with iodine and NaOH. So if acetaldehyde is treated with iodine in presence of NaOH, so now I'll tell you a simple trick to write the product. So here cleave this carbon and carbon bond. Here what is our condition? It should contain 3 alpha hydrogens. No, you just first thing you replace these 3 hydrogens with 3 iodines. Okay, now what it will become? It will become Ci3 and you write the remaining thing as it is. Okay. So here in your competitive examinations, here I am telling you how to write the product in an easier way. Okay. And CI3, no. Now after few steps, what it will become? You break the bond between this carbon and this carbon. Okay. And add hydrogen to this one, hydrogen to that one, and OH or ONA this side. Because you are taking Na, no, NaOH, no. So sodium salt of carboxylic acid you will get. So write down the product. So here you are adding hydrogen, no. So this will become CHI3. Here is your iodoform. Okay. So what here you attach this hydrogen to carbon itself. See, it will become CHI3. Here you are breaking the bond between this carbon and this carbon, no. So you attach OH or ONA to this carbon only. Then what it will become? Here H, C double bond O. Here it is O, Na. O minus Na plus. So it is a sodium salt of carboxylic acid, HCOONA. Clear? That's it. This is your iodoform and it is your product. Forget about the mechanism and everything. Okay? So what are the two steps you should follow? Here if you are given with iodine and NaOH, you should recognize it is a haloform reaction, and here to that alpha hydrogens, whatever the 3 alpha hydrogens are there, you instead of that hydrogens you place CI3. Okay, and after that you break this bond, this carbon and carbon bond, hydrogen to this side and ONA this side or OH this side. You will be getting a sodium salt of a carboxylic acid and an yellow color precipitate, which is nothing but iodoform. Okay, now try to write the product for this one. PH C double bond O CH3. If you are given with iodine, NaOH or NaOI. So here you know it is an haloform reaction. I told you how to write the product. Now without this step, you try to write the product only. So here you replace these hydrogens with iodines. This will become CI3. Okay. What I told you, here you break the bond between these two and hydrogenate, add hydrogen this side, add hydrogen this side, and O Na this side. So what it will become? This will become CHI3 plus PH C double bond O, ONA, that's it. Sodium salt of benzoic acid, sodium benzoate, sodium, because it is acetophenone, no? Common name is PHC double bond O CH3, it is acetophenone. So here C6H5 COONA, sodium salt of benzoic acid and your iodoform. Okay, clear? So just write another example. I will give you another example. Now write the product for this one, CH3, C double bond O CH3, and you are given with KOI. It is oxidation, hypohalite oxidation. So here 3 alpha hydrogens. Here this side, this is also alpha carbon and this is also alpha carbon. Altogether you have 6 alpha hydrogens. You choose any one carbon atom, means any 3 hydrogens. So here I am choosing this one. So here how to write the product? First you add 3 iodines, write 3 iodines instead of hydrogens. So this will become CI3, and here after adding iodines, hydrogens this side, ONA this side. Here you have taken K, no? So you add OK. Okay. So what it will become? So hydrogen this side means here you are adding hydrogen this side. So this will become CHI3, your iodoform, and this will be CH3CO. You are adding oxygen to this carbon atom, O minus K plus. So it is sodium salt, potassium salt of a carboxylic acid plus iodoform, yellow color precipitate. Clear? No, I told you, no, here the only aldehyde which gives the positive haloform test is acetaldehyde, and any ketone containing 3 alpha hydrogen. This is the way to write the product. And also some of the alcohols also gives positive haloform reaction, positive iodoform test. So I'll tell you how to write the product for this one. If at all you are given with this alcohol, isopropyl alcohol, and you are given with iodine plus KOH or NaOH, whatever it may be. So here first, as it is an oxidation, you assume this alcohol will be oxidized to ketone. So what it will become? It will become CH3, C double bond O, CH3. Oxidation. So here how to write the product? Here you just remove these 2 hydrogens as it is an oxidation. And here as you are removing hydrogens from this oxygen and this carbon, so here you place a bond between these two. This will become a double bond, C double bond O. Here is your acetone. And how to write the product for this one? Here simple, like this previous one. This has oxidized to ketone, no? So here this will become, here this hydrogens will be replaced by iodine. So this will become Ci3, C double bond O, CH3, and after that you break that one, break the carbon-carbon bond and add hydrogen this side. This will become CHI3 and okay, O minus base. So here if you add, it will become CH3CO, potassium salt of carboxylic acid. That's it. So potassium salt of ethanoic acid. Okay. Okay. This is about haloform reaction. So I'll discuss a few examples based on this in the next video. Okay. So if this video is helpful to you, then give me one like. Next I'll come up with one more topic. Till then, bye.